My name is Tran, and I'm a first-year Doctor of Audiology student at the University of Texas at Dallas. I'm excited to be presenting my poster, which is entitled Evaluation of Important Factors in Electroacoustic Verification of Wireless Technology at this year's AAA. I would like to thank Dr. Thibodeau for helping me putting this poster together. Wireless technology systems are great assistive listening devices to improve the signal-to-noise ratio and facilitate communication. When an audiologist program and fit hearing aids on a patient, the goal is to provide audibility to the patient based on their hearing loss. Therefore, a wireless technology system should maintain the same output with the output of the hearing aid mic to ensure the patient has enough audibility. It's important for the wireless system to be able to achieve transparency. Transparency is achieved when a 65 dB SPL input to the wireless microphone produces output equal to that from a hearing aid, with the receiver when also receiving the same input. The purpose of the study was to evaluate factors that impact the electroacoustic verification across 18 Phonak Roger X02 receivers. The wireless technology system that I evaluated for this project is the Phonak Roger Inspiral and the Phonak Roger X02 receivers. The receivers were attached to the Phonak Naida V90 SP and the Oticon Open Blade 2 PP hearing aids with appropriate audio shoes. Both hearing aids were programmed for a flat 60 dB sensory neural hearing loss with the DSL V5 for adults, fitting rationale. The AAA guidelines for electroacoustic verification of wireless technology systems specifies the equipment placement and the input levels to be used as shown in this table. The results of the study focus on comparing the second and third measurements, which is the difference between the hearing aid output when the hearing aid mic receives the signal and the hearing aid output when the transmitter mic receives the signal. All measurements were taken with a 65 dB SPL digital speech signal. Two evaluated factors in the study were the designated patient age in the programming software, a 20-year-old patient versus a 70-year-old patient, and the transmitter settings being in verification mode versus not being in verification mode. The difference of the two hearing aid outputs were taken at three frequencies, 750, 1000, and 2000 Hz. An average of the differences at three frequencies should be within 2 dB to achieve transparency. These are four representative graphs of the electroacoustic output curves obtained with each of the hearing aids when programmed for a 20 and a 70-year-old patient. The abscissa is the frequency and the ordinates is the output in dB SPL. On each curve, the green light represents the output of the hearing aid mic, the blue light represents the output of the transmitter mic when in verification mode, and the yellow light represents the output of the transmitter mic when not in verification mode. In evaluating for transparency, we're looking to see if the green and blue curves overlap or stay within 2 dB of each other. It was expected that the yellow curve, which is when the transmitter was not in verification mode, would not allow for transparency. But we wanted to see how much of a difference it would make in the event that this setting was overlooked. Let's take a closer look at the graphs for Oticon hearing aid programmed for a flat 60 dB HL sensory neural hearing loss. Looking at transparency, the output of the transmitter in verification mode achieved transparency for the 20-year-old patient, shown by the blue and green lines matching in graph A on the left. For the 70-year-old patient in graph B on the right, the transmitter output in verification mode was nearly within 2 dB in the mid-frequencies of the hearing aid mic output. However, we saw a lack of transparency in the low frequency below 1000 Hz and above 2000 Hz. The lack of transparency when the transmitter was not in verification mode could be as much as 20 dB difference. The effects of patient's age in the programming software and the transmitter setting in verification mode were also seen with the Phonak hearing aid programmed for the same hearing loss. The hearing aid programmed for a 20-year-old patient was more likely to achieve transparency when the transmitter was in verification mode. However, the hearing aid programmed for a 70-year-old patient lacked transparency in frequencies below 2000 Hz. As expected, a lack of transparency was found when the transmitter was not in verification mode. This table is a summary of the transparency measurements across 18 receivers. The first column shows 4 hearing aids and the designated patient's age in the programming software. The next 2 columns show the data for the transmitter setting in verification mode. The last 2 columns show data for the transmitter setting not in verification mode. The data show the mean differences for transparency as calculated according to the HHLAB guidelines across 18 receivers. A number less than 2 indicates the wireless system achieved transparency. When the transmitter was in verification mode, transparency could be achieved in all conditions except for the Phonak hearing aid programmed for a 70-year-old patient, with a mean difference of 2.82. The number of receivers that achieved transparency out of 18 total receivers illustrates the consistency of the transparency result. The first 3 conditions show consistency across 18 receivers, whereas the Phonak hearing aid programmed for the 70-year-old had only 7 out of 18 receivers to achieve transparency. On the other hand, when the transmitter was not in verification mode, transparency was not achieved in any conditions. It was consistent among 18 receivers that transparency could not be achieved. In conclusion, due to predictive values in the fitting formula, for example the relayer-to-coupler differences, the patient's age seems to play a role in determining the transparency. Having the transmitter set in verification mode is critical during transparency measurement of the wireless technology for verification. When transparency is not achieved, adjustment to the receiver is necessary. These factors should be considered for electroacoustic verification of wireless technology systems to ensure accurate and consistent measurements of transparency. Thank you for visiting my poster. If you have any question, don't hesitate to reach out to me at g.tran1@utdallas.edu.